My name is Lee Atchison. I'm a Senior Director of Strategic Architecture at New Relic. Been at New Relic for about 5 years. Before New Relic, I spent 7 years with Amazon, including AWS. I was involved in some of the early days of AWS back when it was S3 and EC2, and that was about it. In fact, I built the team that's responsible for Elastic Beanstalk, if anyone's familiar with that service. That was my big contribution to AWS. Anyway, I want to tell a story, and I want you to tell me whether or not any of this sounds familiar. It's Sunday, day of the big game. You've invited 20 of your closest friends over to watch the game on your brand new Ultramax 300-inch big screen TV. The snacks are laid out before you, the beer's flowing, you're ready to watch the game. When suddenly, TV goes out, lights go off, the power is gone. The game for you and your friends are over. Well, at least it's over for you. Your friends, they go to the local pub. But for you, it's over. Your special day is gone. You wonder what happened. What could have happened to cause this problem? So upset, you call the local power company. They weren't very sympathetic. They said, we only guarantee a 95% availability in our power grid. Why is availability important? Because when your customers expect your product to work, they expect it to work. It doesn't matter if you have a problem. When they expect it to work, they need it working. So to that end, I want to talk about 3 things that can help you build a highly available product, how to manage your service, highly available service at scale. First one is availability, which means visibility. And to start with this, I want to tell another story. This one, though, is a true story. And this was an overheard ops conversation at a company. I won't mention the company's name, New Relic, but it was an overheard conversation among a couple of ops engineers. This is how the story went. We were wondering how changing a setting on our MySQL database might impact our performance. But we were worried that the change may cause our production database to fail. Since we didn't want to bring down production, we decided to make the change to our backup replica database instead. After all, it wasn't being used for anything at the moment. We all can guess, of course, what happened next. And yes, this was a true story. Keeping your application running at scale involves understanding the resources that you're using for your application, what they're doing, understanding why the work they do is important, and observing how they're performing their job. New Relic is the observing part. Full stack visibility, application performance monitoring, infrastructure, and cloud monitoring are necessary in order to give you the visibility you need to make sure your application stays available. Because your application performance is critical, but what really matters is your user experience. Your user experience based off your application is what really drives your business success and ultimately your business outcomes. Because nobody wants this. So now, I want to move on to the second point, which is how to make availability happening by using the dynamic cloud. What do I mean by the dynamic cloud? Well, there are 2 ways that most people take advantage of the cloud today. The first is what I call the better data center approach to managing the cloud. The second one is using the cloud to build dynamic applications in a dynamic environment. Let me talk about each of these very quickly first. Better data center, what do I mean by that? What I mean is resources, whether they're servers, databases, whatever the resources are allocated to specific uses, just like they are in a typical data center. The provisioning process, of course, is much faster in the cloud than it is racking up a computer in your own data center. but the lifetime of the resources that you allocate are still quite long, just like they are in your own data center. You allocate a server for a purpose, it lasts for days, weeks, months, years. And such, traditional capacity planning is still an important part of the process. You create a computer to run an app, you create an instance to run an app, that server is assigned to the app's assigned to that server, it's a static connection, and everything runs smoothly, just like it does in your own data center. Smoothly. So why do people use the cloud in this manner? This is, by the way, the typical lift and shift sort of use of the cloud. Well, the reason why people move to the cloud to use the cloud in this way is for adding new capacity faster, to improve availability by adding new data centers easily, quicker, and capacity where you need it, which you might need for compliance reasons and things like that. People do it just for the same reasons why they allocate new servers and new data centers. They just use the cloud to do it faster and presumably cheaper. But the dynamic cloud is different. When people build dynamic apps using the dynamic cloud, it's a very different use case for the cloud. In this case, you allocate only the resources you need for the app at any given point in time. You allocate and deallocate the resources on the fly as you need them. And most importantly, the resource allocation process itself is an integral part of your application architecture. Resources, servers, whatever the resources are allocated, they're consumed, they're deallocated, all as part of the application itself and the process of the application goes through. To demonstrate this, we decided to take a look at some of our Docker data. This is data for all the Docker containers from all of our customers in aggregate that are monitoring their Docker containers using New Relic. And we want to ask one simple question. How long does a typical Docker container run for? So we got all the data and we show along the bottom edge number of hours, and the top edge is how many containers ran for that period of time, historical data throughout time. And you can see the longest running Docker container, still running today, 833 days, over 2 years. That's a static use of a Docker container. That's a static use of a server. But you see that most of them run for a very short period of time. The far left-hand column represents a 1-hour sample. These are containers that run for less than 1 hour. We thought that was interesting that particular value was such a high spike. We took that 1 hour interval, just took that data and expanded it out to see what that looked like. And we saw this. Turns out that over 11% of all Docker containers that New Relic monitors today have a lifetime of less than 60 seconds. And these aren't containers that fail during startup or have problems. These are containers that are start up, perform a business function, and terminate in less than 60 seconds. This is what I mean by the dynamic cloud. This is resource allocation for a particular purpose that's only made available while that purpose is needed and is terminated when it's done. Resources are freed when it's done. That concept of dynamic resource utilization applies not only to Docker, but certainly to EC2 instances. Auto-scaling does that, but you can allocate EC2 instances fast or slow as necessary. If you look at a lot of the mobile and IFT APIs within Amazon, a lot of them follow the same sort of concepts. Queues, we have customers who create SQS queues for single transactions, and they delete the queue when they're done. Resource allocation at a very small level for a specific task. The dynamic cloud allows you to build applications that run faster than traditional data centers, faster than the static cloud. But the way you build the apps And the way you do things, the way you monitor the apps, the way you run your operations team is different than in the past. Nothing's the same anymore. This happens because EC2 instances, you allocate that might only be used for minutes or hours, Docker containers for seconds or minutes. But there's another trend in this dynamic cloud capability that is even more dynamic than Docker containers. That, of course, is serverless, Lambda in the case of AWS. Well, for servers, you might allocate them for a small number of hours or minutes, and Docker containers for seconds. Lambda functions are designed to be allocated and run for milliseconds and terminated when they're done. Very, very, very short, very precise resource utilization. They're designed to be highly dynamic, incredibly scalable, with no infrastructure that you have to run, but of course they run on a massively shared infrastructure on the back end. So when you need additional Lambda functions running at any given point in time, you use capacity that's available to you on a massive scale that other people aren't using at the same time. The size and scope of AWS allows this sort of resource sharing to fully make it such that Lambda functions can be run and scaled at nearly an infinite level. You can have a single Lambda function run at near infinite scale without any configuration or infrastructure monitoring or management necessary. This is really the future of the dynamic cloud. This sort of resource allocation, this sort of management of resources is the way that the world is moving in a dynamic cloud. The dynamic cloud allows you to scale your applications easier, but it also allows you to respond to changes. Your development teams respond to changes faster, implement those changes faster, and roll them out faster than ever before as well. Together, these two things in a dynamic cloud helps improve availability. And is necessary for the availability for a lot of our applications with highly dynamic scaling needs, with huge unanticipated spikes. How many of you have a business that has huge unanticipated spikes? Serverless, along with the other dynamic cloud capabilities, is the heart of the future of making those sorts of those sorts of applications run at the scale you need to handle the resource demands of your customers. But there's an interesting problem here. How do I monitor the dynamic cloud? How do I monitor resources in a dynamic environment? If we look at an application, and we think about the AWS monitoring that goes on in a cloud and the New Relic standard application monitoring and infrastructure monitoring that goes on. And this monitors most of a modern application of a dynamic application. But there's a piece that's missing. This piece is now part of your application. The resource provisioning process is something that has to be monitored as well. How do you monitor that? Well, how do you monitor something that didn't exist 10 minutes ago, or that was running 10 minutes ago and doesn't exist now? It matters not only that you monitor the resources that are available and running now, it matters what resources we're running, and it matters when the resources were running. Because when you're debugging a problem that occurred 10 minutes ago, it doesn't matter the resources that are available now, it matters the resources available then, when the problem occurred. Remember the Docker data. Containers last for 20 seconds and cause a problem while they're running. You need to know when not only that it caused a problem, but when it caused a problem and what customers were impacted by that. So monitoring the dynamic cloud involves not only monitoring the resources and the components themselves, it means monitoring the life cycle of those resources. Now, New Relic does provide capabilities for doing this. Our infrastructure product has a great capability for monitoring these dynamic resources. We're adding capabilities all the time to APM as well to help make this monitoring easier. But this is new ground for all of us. And so as you build these dynamic apps and start using New Relic to monitor these things, let us know what things are missing. Let us know what problems you run into, because that's what's going to feed future innovation and help us make sure we give you the features you need to monitor these very dynamic applications. In the static world, your ops teams like to maintain spreadsheets of serial numbers of servers, right? It's like, these are the servers I own. These are my precious machines. These are the machines that I care about. And that worked fine in the old world. It doesn't work anymore. There are no serial numbers of spreadsheets of resources. Not even instance IDs, right? You've got resources that are coming in and out of existence at a rate of seconds. There's no reason to keep track of it that way. In the dynamic world, things can't be managed the same way they were in the static world. So that's the dynamic cloud. Of course, to take advantage of the dynamic cloud, you have to be on the cloud. And a lot of us still aren't there yet. So, migration. How many of you have moved to the cloud successfully? How many of you have moved to the cloud and it hasn't quite worked for you yet? You don't have to raise your hand, but I know you're out there. I talk to a lot of customers, and you'd be surprised the number of customers I talk to who still think that they can't move to the cloud because it's too hard for them, or they've tried and failed at certain applications. A lot of people in this room take the ability to move to the cloud for granted, but for a lot of enterprises, it is still a hard challenge for them to manage. They set high expectations for themselves. When problems occur, blame, finger pointing goes on. And the pressure to declare victory in anything when you're moving it. We move this one thing, isn't this great? It works fine. The pressure to declare victory wherever you can is high. But that's not enough, because as you do that, does any of this sound familiar? Where were the performance gains you expected? Where were the cost benefits I expected? Well, they'll come eventually. We haven't seen them yet, but they'll come eventually. Why is it taking so long? Why is it taking 3 times longer than you said it would take? And all these new apps you promised, where are they? Well, the politics of migration are hard. Politics of migration are something we all have to go through. But moving to the cloud doesn't have to be painful. But to move an application successfully to the cloud, you must move in a controlled way, learn as you go, and most importantly, measure everything as you go. So I find there are 6 basic steps that most companies go through, cultural maturity, if you will, that the companies go through in their cloud maturity as an organization. They become emboldened by the cloud. While these are standard steps, not all companies follow them exactly in this order, and some skip steps or find skips are unnecessary. But basically, some aspect of all 6 of these steps are done by everybody. Let's go through them. First one is experiment. In the experiment phase, that's when you say, hey, let's take this one little thing, let's use the cloud for this one simple little piece, this one little part of the cloud, and just kind of test things out and see how things work. S3 is a typical use case, right? We can store some things in the cloud. We'll use the cloud that way, in a real simple way. Stay away from servers, you stay away from EC2, stay away from all the sophisticated, complex, dynamic things. But you do this all as a one-off test, or a team or a couple of teams in your organization do a one-off test. This is all about figuring out what this cloud thing is. Most companies have gone through this stage by now. Not all companies, but most companies have. Next step is secure the cloud. This is a step where other parts of your organization gets involved in the process. This is where policies start getting formed on how to use the cloud, what we can do with the cloud, what things can go in the cloud, what things can't go in the cloud. All parts of your company are part of the process here. This is kind of a critical evolution point for your company and its cloud future, and at a point of time when the culture of your company starts changing. This is the can we trust the cloud stage. The third stage is servers. Servers and other back-end resources. This is typical lift and shift. Let's just move an application to the cloud, see what happens. Well, we have servers, they have servers. We have databases, they have databases. Just move to the cloud and see what happens. You might do this as part of a multi-data center resiliency plan, or start using some SaaS services, a bunch of things like that. But basically, this is where you start saying, yeah, the cloud's working pretty well for us, and we can start taking advantage of some of the features of the cloud, realistically. Fourth step is value-added services. This is where you start saying things like, okay, well, now that I've got a database in the cloud, I still have to manage that database, but AWS or Azure or everyone else has managed databases. Why don't I let them manage the database for me? You start using managed services, whether it's RDS or Aurora. Start using things like Elastic Beanstalk and other Elasticsearch and other more higher value services in the cloud. This is where the dynamic cloud starts taking effect, where you start thinking more about dynamic applications and the use of those resources. The fifth step is unique services. In the previous step, you became committed to use the cloud. In this step, you get committed to using a specific cloud provider. This is where you start using high-valued cloud-specific services like Lambda, DynaDB, things that give a high level of value, high level of scalability. They're designed and built for the dynamic cloud, but are tied to a specific service provider. This ties you to AWS, or it ties you to Azure, or it ties you to Google. And this is a point of commitment where you become dependent, highly dependent on the cloud. And the dynamic cloud becomes deeply ingrained in the culture of your company. The last step is mandate. Well, now we have these data centers that have all these cloud resources. This is where you ask the question, why do we need our own data centers? This is the ultimate immaturity level of the cloud. This is where you say, we're all in on the cloud. We're not going to do anything in our own data centers anymore. In fact, we're going to get rid of our own data centers over time or immediately. Not a lot of companies do this yet. More and more companies will in the next several years. But this is the last stage in that maturity process. These steps aren't easy. They're not fast. Different for every company. But these are the steps that all enterprises go through. But there's also a set of steps that the applications themselves go through that's different than the steps and the phases that the company goes through. They go through it at a different rate. Your certain applications may go through this migration faster, other applications slower than your company as a whole. So you can look at these two things on a two-dimensional matrix, and you start seeing, and you can start plotting where your applications fit on this. And in experiment stage, we do the first steps in the cloud. And then you might start looking at non-critical applications where they make heavy use of the cloud, but early in the maturity of your company culture itself. As your company culture matures, you start moving new applications that are being developed to the cloud. And as your corporate maturity increases, you might start doing application rewrites. But now you're talking about critical applications that you may not use quite all the features of the cloud. So the application itself isn't as mature in the level of features that it uses in the cloud. And ultimately, critical applications. You do those last. You'll typically only use the parts of the cloud where you need. Maybe just a lift and shift, nothing more than that. So you don't want to be rewriting these. You don't want to be controlling these. And what it turns out, if you look at the different types of services that are available to your application during each of these times, and the services that are available in the cloud, the most popular services end up in this kind of sweet spot where it's very easy for applications to move a certain level to the cloud and and stay there. And you come to maturity to go to a certain level of maturity and kind of stay there. Not likely to go beyond as fast as it takes you to get to this point. What we find is the most common services in the cloud fall in this sweet spot. Center of gravity, if you will. So I'm moving to the cloud. How can I be successful moving to the cloud? Understand what your culture is of your company. Understand your needs. Consciously plan your acceptance. Drive the cultural change necessary within your company. And monitor the adoption. When I say monitor the adoption, what I mean is before the migration, get baselines of how your applications are working, determine a steady state of how the application works. During the migration, incorporate the cloud monitoring in your solution, but then monitor the application itself continuously during the migration, because deviations in performance you see during the migration are indications of problems, early indicators of problems that you want to catch to resolve those before you move on to later stages in the migration. Understand and solve all those deviations before you move on. And then after the migration, continue monitoring, because this infrastructure is now outside of your control, and there's some cloud things that can happen. EC2 instances do fail. You want to know when a problem is a cloud problem versus your application problem. That's now critical because the infrastructure is outside of your control. Before, during, and after the migration, all three phases are critical for monitoring your application to make a cloud migration successful. So that's migration. All three of these are steps that can help you build your application high availability, work at scale. And the center of all three of those is monitoring your application and monitoring your infrastructure. It used to be that monitoring just a server was all it took to monitor your application. But in a dynamic world, you need much more than that. You need a full stack monitoring, because you don't want this to happen. You don't want that to happen. The way you've done things in the past doesn't work in the future. Full stack monitoring is what you need. Thank you.